to start with a short round of welcomes from the Ministry of Economics, from the European Commission, and then we'll know more about what national statistics institutions need in terms of statistics and what could be potentially covered by Earth observation. And then we'll have presentations from European institutions on what Copernicus can actually do for national statistics. Then we'll welcome you for a Q&A session. We planned quite a lot of time for this, with a hope to really think of some steps to develop this direction of Earth observation and national statistics. So, for the first speech, I would like to welcome Mauro Facchini from the European Commission to give us a context for this event and to say nice words.
Yes, thank you very much, Angelina. First of all, can you hear me? Can you see me? Yes. So, good morning, good afternoon to everyone. It's a pleasure to be with you. I want really to thank the organizer. Angelina, I remember we had some contact last year when we started to think about this meeting, and I'm very happy that today it's taking shape. So thanking you, Eurostat, and all the colleagues that made it possible. It's a kind of a unique opportunity to present to Latvia, to the Baltic state, but also to the European statistics community what Earth observation can do. Actually, in my function as head of Copernicus, I'm very proud to share with you what we can do in that respect. It's true that when we think about the statistics community, it's I think they have not been among the first users of what we are doing, but I think the interaction between what we are doing in Copernicus and the statistics community is growing ever and ever. I think we have a better understanding of what we can provide, what are the needs of the statistics community, and we hope that today this event is a way that can be used in two directions. In one direction is for the Copernicus side to explain what we can offer, and on the other side, what the statistics community can get out of that. What are their interests? What are their worries? What are their concerns? That actually we put together two communities in order that they speak more and more in that respect. Internally to the European Commission, we have already started since a while interaction with our Eurostat colleagues, so we understand each other. I think that work is progressing quite well, and integrating also Earth observation more and more in statistics, but also in aspects like, for example, environment ECVs, where we see more and more that the use of Copernicus is there. So I don't want to keep more of your time on that. It was really just to give you an insight into that. And I'm very happy that so many people decided to register for this event. I see now more than 330 connected. So I wish you a very good meeting, very productive. And it's just it's not the end of the trip. It's just one step in what we are doing. And I'm quite sure that after this event, we will be able even to understand better each other and to make sure that Earth observation products from satellites and other sources can be made available for statistics. Thank you very much, and a good continuation.
Thank you very much, Mauro. And good news, I already see in the chat that also institutions from other countries are joining us to see what's going on, as well as our industry. Our industry, I mean the European industry in Earth observation. So for the next welcome, I'm also inviting Marta Nagy-Rotongas from the European Commission.
Good afternoon. Thank you very much, Angelina. I would like to start also with a very warm welcome of all participants and also all the co-organizing institutions. For us, for Eurostat, it is a very important occasion today to discuss with you together which kind of opportunities the statistics have from Earth observation. I would like to thank specifically Latvian government, and of course in person you, Angelina, for the initiative. We are very pleased to be part of it. I also would like to thank Mauro and his team for the good collaboration and for the opportunity that we can use infrastructure for DEFIS and from Copernicus for statistical purposes. Why is it important for statistics? Because we believe that Earth observation data could be an alternative source, a new source for producing maybe quicker, more efficient statistics, saving time and costs for our public administration and for our countries. Many national projects and international projects have already proven that Earth observation data can be very useful for statistical purposes. We do not have yet the global solution, but we are working on it. It has also an institutional push in the statistical community. I would like to remind you that in October 2021, the Director Generals and the presidents of the National Statistical Institute in Warsaw decided to work more intensively in their countries, but also in the European statistical system on using Earth observation data for statistical purposes. This is what we call like the Warsaw Memorandum, which was followed also with an action plan, including activities on infrastructure, innovation actions, skills, mapping, etc. So we are now in the progress of doing it. And today is an important stop or an important occasion to put this to the knowledge of many other countries. We have invited also the task force from 14, 15 different member states. So we will follow the Baltic countries line. And I'm very pleased that it is even a cooperation, a regional cooperation in the Baltic countries. So all of the 3 countries are cooperating here. I wish you a very fruitful, informative, and information session in that. Thank you very much.
Thank you very much, Marta. Now we had a word by our Deputy Minister or Parliamentary Secretary of the Ministry of Economics of Latvia, Jurģis Miezenis. But let's see if he could connect. I'll need the help of the European Commission. Okay.
So
Silence, it means there is a problem.
no, I would just need, I'm checking now, we just need to see, I don't see him connected.
Okay, so probably there is a issue with this. Maybe we'll move this address for a bit later. Or we'll consider that Mr. Miezenis said that it's very important what we're talking about here, and sharing is caring, so he will share his 5 minutes with us for our Earth observation discussions. Okay, so maybe we can move forward with the presentations of the National Statistical Bureaus. And here I'd like to give a word to Raimons Lapiņš, the first supporter of this initiative. Thank you very much for your interest in Earth observation data. Raimond, you have a floor.
Hello, good evening. I'm glad to be there. I will a little bit touch on already mentioned things, why we care, why it is important, and why statistics is interested in space technologies. So I will cover in my presentation by setting the scene, some examples from Latvia, and let's look ahead what can be done more. From our perspective, one of the most important challenges what in statistics sphere we will have is everything related to climate neutrality and ensuring adaptation to the climate changes. Why it is so? It is because everything related to climate changes and climate neutrality is pushing to the limits our ability of data-driven decisions. Huge amount of data, majority of events influencing climate changes and environment changes and our actions is taking place not in our location but globally, but actions have to be taken locally. The same applies to how we see climate changes, and we see them on the ground. Storm is going on in my location. Reasons are outside of my perception of my scope of influence. So over the past years, Latvia have been facing several significant floods, storms, which have been negative effects to Latvian economy, quality of life, living space. Until now, responses to these natural events have been delayed. From perspective of for people living in this country, it have been delayed. And these delays of prediction, what will be happening, is hindering our ability to take actions before bad things are happening, and it leads to bigger losses, and both in public and private sector. In future, every level of the decision making, whether it's public sector, private sector, sectoral policies, and all these decisions will need much more accurate historical data and data to take predictive actions and predictive decisions. Advanced analytical tools like artificial intelligence clearly will define and will play a pivotal role in using of this data and for sustainable economic development and environmental biodiversity preservation and population well-being. It will be very crucial to base these decisions on reliable data analysis and forecasts. What we have, what tools and data we have available will quite significantly define what our companies, what competitive advantages they have, because access to the as precise data as possible in corporate sustainability reporting will be crucial to develop their strategy, to take their choices and generate value added what they have to do. What is very important, it is not only that these decisions are living separately in their environment, it have to be the same data have to be used in official statistics, that we can firstly reuse data, but secondly that we can compare our actions in more broader playing ground, not only in Latvia, but that we can compare our actions with our neighbor actions and actually influence climate change. In this field, georeference data is becoming cornerstone. So localization of data, putting it on the map, gives two strong points. It gives us opportunity to understand what is going on, what is context of all of this data, and secondly, it leads to more localized, more precise decision on the ground. So in European statistics systems, georeferencing data is becoming one of the most important development areas. As it was highlighted in European Statistics Forum, cooperation between statistical and geospatial communities to standardize efforts is vital to ensuring data reusability. We are not only looking forward and imagining what will be happening. In Latvia case, we are building and some of best practices which we are proud of is linked both to European fund decisions in, for example, in grassland data, successful examples of cooperation between Central Statistics Bureau and Rural Support Center, where we actually use satellite data to analyze grassland in Latvia. Then in forest and forest health monitoring, forestry is one of the largest industries in Latvia, and forest health monitoring translates directly to GDP. So Riga Forest company is including monitoring and mapping tools from space to assess damage caused by winds, insects, and wildfires. Then State Environmental Service is using mineral extraction monitoring system, again, space-related data to actually monitor how much we are extracting from our land and how to do it more sustainable. And latest developments involve testing illegal construction management, so increasing productivity of state management of construction services. So use European Cosmos Agency's, Space Agency's data in incorporating in their decision making. Statistic institutions and we like to talk about being very innovative, but we have to keep in mind that we are conservative for a reason. We are conservative because all the data which we are produced have to be comparable, at least in European level, that we do understand what is consequences of these numbers. So from one side, we are innovating and introducing new data sources, but we have to keep in mind that this standardization is very important, that we actually can compare data in European space. From this point of view, I think that interest and readiness to use space data in statistics just proves that space is not anymore rocket science. It's becoming day-to-day tool for both decision making and each day's livelihood. So where we're looking ahead on collaboration and integration in the future, we know, at least in the Baltic region, we clearly know that environment have a distinctive value and it can be calculated in euros, in GDP. So ecosystem mapping, and in this time, not economical ecosystems, but real biological ecosystem mapping is one of the challenges which we face. And we see that space data, data from space can be used to map these ecosystems much more precisely. And we look forward what can be done in this field actually to integrate this data in official statistics. And as a result, we can monitor what changes, what decisions do influence changes in ecosystems. Second part is renewable data, renewable energy data, particularly, at least we know, as a low-hanging fruit, we see solar energy infrastructure, but as more and more decentralized energy production is going on, we see that there is more and more opportunities, not only probably in this solar energy field, but in any other renewable energy fields, we see opportunity of using data from space. Challenges. The biggest challenge is to find a ways to transform this unconventional data to data source which is reliable enough and high quality that it can be used for statistical purpose. And as I mentioned already, and I re-mention it because it's very important that it can be standardized and used as a tool in future. In this sense, Baltics have been playing this role and we will be playing future too. For any standards, we need places to test ideas and test standards. So I can say that at least we as Latvian, I know my Baltic colleagues is completely the same. We are ready to test ideas and then show outcomes and show what can be done with new tools and how to standardize. I want to say very big thanks to Angelina from Ministry of Economics and all the Ministry of Economics team, Commission, for their contribution to organize this event, for Eurostat supporting and being at the forefront of innovation of statistics and helping us to do the same. And our Baltic colleagues, which I see that whenever we are coming up with crazy ideas, they are always open to listen to them and look forward. So thank you very much, and I'm expecting great results from this seminar. Thank you.
Thank you very, very much, Raimond. Now let's give a word to our colleagues from Estonia. Kaia Oras and Madli Linder from Statistics Estonia are going also to present their viewpoint on national statistics and what we could do together with Copernicus for this. Thank you.
Yeah, thank you. Just a small clarification. I'm Kaia Oras, Statistics Estonia, and we have Madli Linder, who is the representative of Estonian Environmental Agency, which really started now to work together, hands-on on the data. But first, let me try to share the screen. Just a second. Just a second. So could you? So do you see my slides in PowerPoint mode?
Yeah, yes, we do see them correctly. Thank
Okay,
you.
thank you. So once more, yes, good morning, everyone, and thanks for inviting us to talk and share how and why we use Copernicus data. I already introduced us, so once more, Kaia Oras, Statistics Estonia, lead expert environment statistics accounts, and Madli Linder, real experts on also spatial data, but a lot of environmental issues in Estonian Environmental Agency. And I try to get to the next slide. Yes. Okay. Where do we use Copernicus data? Starting from this year and the initiative, which is now underway in Statistics Estonia and in collaboration with the Environmental Agency, we have ecosystem accounting work stream, and this work stream for sure needs for certain ecosystem services needs Copernicus data for what ecosystem services to be monitored. So that's for sure. And we will see some examples. But in addition, agricultural statistics already for some time indirectly is benefiting from Copernicus data, which refer for crop statistics, and it's related to the soil monitoring systems. And it's based on Copernicus Sentinel satellite images. And this is already ongoing for some time, but we are kind of indirect users. We are not hands-on working on these data. And regarding future needs, Estonian Environmental Agency has started to compile the forest mask for forest area and respective changes. And it's again Copernicus Sentinel satellite images plus other data sources. And later on, this data will be used for the modeling also the growing stock. And where, of course, this is also related to the needs of official statistics, new regulation reporting on the environmental economic accounting, forest accounts, improvement the quality of the data. And what is novel stream as well coming up is statistics on the nutrient balances and the grasslands production. We will now starting development work on nutrient balances, and we will investigate the feasibility of using Copernicus data for the grassland production. So, and regarding ecosystem accounts, the blue lilac area here indicates the work on official statistics, but for producing ecosystem accounts, a lot of basic data are needed, a lot of most spatial data, and some of those are Copernicus data which are needed. For ecosystem, and this is the bird eye view how our regulation now has progressed. So very quickly coming in 3-4 years. Now it's now adopted and first data report in 2026. Also, Latvian colleague mentioned this new demand. And here I highlighted in bold these ecosystem services data we use Copernicus for. These are local climate regulation, air filtration, and there is a voluntary indicator on flooding mitigation, but national policy level. So, and here we have outlined those here, these first the components of ecosystem accounts like extent accounts, which for what we do not use the Copernicus data, but for ecosystem services, like I mentioned, air filtration, local climate and flooding benefit from Copernicus data. And we have ecosystem condition accounts, and where Copernicus data are used have been tested their use. And it's feasible to use them among with other data sources. And I highlighted those in bold italics, which are used as alternative data sources. And let's look at one of a service, climate regulation. So ecosystem service is cooling effect. And here there are 3 data sources which are input to this ecosystem service calculation. Landsat data, there is Copernicus data on tree cover density, and evapotranspiration data from Google Earth Engine. And here we really work together with our environmental agency, and Madly is already showing her face, and she will tell us the details of this modeling, and then we'll also look at the flooding ecosystem service. Yeah, over to you, Madly.
Yes, thank you. Can you hear me?
Yeah.
So yes, Madly from Estonian Environment Agency, and you can put the next slide, please. So as Kaia said, we have tested some ecosystem services accounting indicators, and one of them is the cooling effect of vegetation or green areas of urban areas, and this is very important because the duration of heat waves has increased and shows a statistically significant trend, and especially urban residents are very vulnerable to climate change, facing threats from heat waves. So next slide, please. And as Kaia said, we have tested this ecosystem service of cooling effect of vegetation with 3 datasets. One of them is land surface temperature that is derived from Landsat 8 and 9 images from the red, infrared, and thermal infrared bands. Then we used Copernicus layer of tree cover density that is ready-to-use product, and also evapotranspiration data that is required from Google Earth Engine. Next slide, please. So we tested this data on 3 largest towns in Estonia, that is Tallinn, Tartu, and Narva, to find the cooling effect of vegetation and green areas in degrees, Celsius degrees. And we made some regression models and to combine this data, and the result is in the next slide, please, where we attributed these cooling effects in Celsius to the specific ecosystem types also. And also the contribution of the specific ecosystem types to total cooling effect was weighed by the area of ecosystem types. So here we can see how much each ecosystem type contributes to this cooling effect. And in this case, we statistical office attributed all this service to the use of the service or consumption of the service to the households, their final consumption. And this is the cooling effect is in total is in average is 2.04 degrees. Next slide, please. Yes, then the second example of ecosystem services that we tested is flood control ecosystem service. We used Sentinel-1 based Sentinel-1 satellite images based operative service on open water extent, that is flooding events, which is available from the web page of Estonian Environment Agency. That is a operational application. We downloaded the data of the last 5 years from there and used it in combination with the data from the National Ecosystem Services Assessment and Mapping project called ELMA, from where we got the maps of water flow regulation capacity that is based mainly on the national soil map, and ecosystem services demand map that is mainly based on the population density and accessibility. Next slide, please. And the main result or aim to do these calculations was to find the ecosystem services provision on flood-prone areas of economic significance. That is 2 ecosystem services classes, that, which are settlements and croplands. And here you can see how much these two how large is the provision of this ecosystem service in these 2 types of ecosystems in Estonia. And in this case, the provision of the ecosystem services, in the case of the use of the ecosystem services, was divided between 2 users, which are intermediate consumption by industries and households. And we can also calculate the monetary value of flooding mitigation, but we don't have time to go into detail with this. Next slide, please. The satellite-based operational service of open water extent is mediated and processed through our national satellite data center called EstHub, which is an advanced platform for remote sensing data enrichment and innovation. And competent authority here is Land and Special Development Board. Next slide, please. This EstHub has 5 main environments, which are listed here. The main and the easiest is Satiladu, which is a viewing application to view satellite data, and also other spatial data is available there, which can be combined with satellite data. The area of interest there is Baltic states. You can view Estonian as well as data from Latvia and so on. And you don't have to have a user account to use Satiladu. If you want to download satellite data, you have to make a user account. And if you want to process data in EstHub, you have to make a contract. And our land board very welcomes other users from Latvia and Lithuania also to use EstHub. There are also possibilities to compute large data flows, mass processing in Corvalus computing environment. You can process 120 parallel processes there, or if you are not so experienced user, you can use Jupyter Hub, which is easier environment where you can compute, analyze, test prototypes, and so on. And you have direct access to the satellite data there. You don't have to download data to your computer. And there are also data groups. At the moment, there are 2 different data groups available that provide time series about water quality and NDVI. So you can use these also. And if you want to make a user account or contract, you can contact people from Landport. You can find information on the link above this slide. Next slide, please. There are many possibilities for the future. At the moment, the Estonian Environment Agency is launching, in cooperation with European Environment Agency, a national collaboration program to promote the use of products of Copernicus and involve countries, collect user requirements, validate the quality of the data, and increase the uptake of the Copernicus products. There are, of course, still some limitations. A few are listed here. Depending on the task to be solved, still low temporal and spatial resolution and lack of local validation data is the problem. That is in the case of ready-to-use Copernicus products. And in the case of raw satellite data, that is in the case of optical images, still the clouds are a problem. Yes, and with this, I think we can finish at the moment.
Yeah. Yep. Thank you, Matti, very much from your side for this insight. And as we noted in the beginning, that this is a viewpoint from a need of official statistics. There are many other uses of the Copernicus data in environmental agency and other agencies in Estonia, but this was clearly the viewpoint from a viewpoint of official statistics reporting demand. So how we could make a best use of a Copernicus possibility. So thank you from our side for listening.
Thank you, Kaja and Madli. Your S-Hub has a fan, me, and my secret dream is that one day it will be a Balt Hub, but just saying, thank you very much for your presentation. And let's invite our Lithuanian colleagues. Ernestas Dicevičius with Saulius Urbanas will present their viewpoint from the State Data Agency of Lithuania.
Yes, hello. Please confirm that you can see my slides.
We can hear you, and we see your slides, but yes, perfect.
Okay, great. Hello, everyone. My name is Ernestas, and I represent the State Data Agency of Lithuania. Now, this is a joint presentation since our experience with EO data and Copernicus data is rather narrow at the moment. I will just briefly present a real-life scenario of how we implemented Copernicus data into our workflow and use it for experimental statistics with potential to make it official statistics. Now, before I do that, I think it's important I mention the 2 main courses that EU data, at least theoretically in our case, could be applied in help of preparing official statistics. And these 2 topics are obviously very similar to all of the NSIs, and this is agriculture statistics and surveys and land use statistics and surveys, for which we could use Sentinel-1 and Sentinel-2 products respectively. Now, below, you can see the 2 examples of alternate data sources for these courses. And since this is our vector data, and I will not go too much into detail about it, just the fact that on the left you can see an example of crop classification vector data, which would contradict the Sentinel-1 classification algorithm, and on the right you can see our national georeference base cadastre of Lithuania, which we use for ecosystem calculations. Now the challenges we face and reasons why we are not that actively implementing EO, specifically into national official statistics. These are mainly based on Sentinel-2 imagery because we did an experimental statistics workflow that I'm going to present. And the main challenges I would exclude are high infrastructure costs, which come from large GPU calculations. So you need sophisticated systems to develop the algorithms, to train them, to fine-tune them, and to do the classifications themselves. This is probably viable for Sentinel-1 as well. Now, the second one is relatable and high-quality sample data. This is a problem that occurs to pretty much everyone, I believe. We have good sample data, the mentioned georeference-based cadastre of Lithuania. However, it's not always the required, I would say, generalization. And as you will see later, we need to reclassify it again. So there's an added layer of additional task. Now, the last two challenges I've excluded are basically go toe-to-toe together. So the complexity of the workflow itself, the development of the algorithms, and the cloud abstraction removal, I would exclude it also as a separate algorithm you would need to develop to even start classifying the data. So you need to a good source of images. So you need to remove the clouds, interpolate the data, prepare the images for model training, and then classify them. So this is probably a two-part workflow. Now, moving on to the actual example I mentioned in the beginning, I will shortly introduce the mentioned workflow we used for land use classification. So the main idea of this was to recreate a Korean land cover dataset for Lithuania, but for our desired time period. So, for example, the minimum time period was once a year. And we actually made an application with the results of this. So I will happily share the link to it, maybe in the chat or maybe with the organizers. Now, for this, we used a pre-trained model as a framework and retrained it with our own data, basically. To retrain the model, we used the mentioned georeference-based cadastre data of Lithuania and reclassified it to fit the Korean land cover classes. So you can see the process here. On the left, there are many cadastre classes that were reclassified to land cover classes. For training, we used standard ArcGIS learning packages and tools with Jupyter notebooks. And the results, well, they were iterated many times, and the final ones are displayed here and also in the application I mentioned. In some cases, for example, water bodies, we managed to reach over 90% accuracy. However, in other cases, for example, clustered urban areas and distinct natural ecosystems, the accuracy was often around only 80%. So this is basically the reason this never made to official statistics yet. Maybe you will someday. And yes, that's it from me. And now I would like to give word to Saulis Urbanas from the Ministry of Environment of Lithuania, who will present a much wider and practical view to the needs of EO data and solutions, not only for our NSIs, but for other national institutions as well. So yes, thank you.
Hello, everyone. To share my slides. Hopefully you can see my slides. Do you?
Yes, it's perfect.
Great. So yeah, I'm sorry that we have decided actually to have a slight view to the data that we're using at national level, not only limiting with the national statistics, but also because we like to have a compliance to what we're doing in statistics, also to have a reflection in other areas. So Ministry of Environment, which is I'm representing here, is responsible for the state policy on spatial data in Lithuania. So we try to guide all public authorities to use authoritative sources of the national data, plus the authoritative sources of the data coming from European Union or other suppliers. So in Lithuania, we have a set of the data sets, the national data sets, which we're maintaining at national level, obtaining the incremental updates, despite the fact that the whole country is mapped on the high resolution orthophotos in the cycle of 3 years, which we intend to move now to the 2 years. But the vector data sets are maintained actually in more regular basis, almost in the certain segments as a dynamic data. And our main in situ reference data set, which is used to connect different cadasters, registers, and information system, is called reference-based cadastre. So the example you have seen in the Ernesto's presentation, and also we're developing other data products that are freely available in our national geo portal for all public authorities and private users. So those are open data actually for everyone. Important fact is that on the satellite images, we see the opportunities to include them in the various elements of national spatial data infrastructure. So the first actually for assuring the quality control of the high resolution data and products we used for the different applications, but also as an important source data for using in the updates of our national data sets, and also to use in different thematic applications. So as an interesting example is that from this year, we continue to explore the Sentinel's information in different applications, but also 15 authorities, public authorities, have signed the subscription to Airbus and Planet imagery data, which we intend to use on those tasks devoted by government of those 15 authorities. And those are contributing to the further learning and actually applying the satellite data in national activities. Talking about the direct uses of spatial data and statistics, what's related with land cover. We have a land inventory data compiled on an annual basis, and currently we use the national data because this is there on the high resolution and the more frequent updated information for compiling the statistics, but also for double checking and making the control of this information. There is also demand to use more and more this light as data as alternative data sources. So this information is compiled also not only from the remote sensing information, but also from real estate registry and the land information system. So from those information system, we're getting the annual status of the officially registered land and also unoccupied land, or the state-owned unoccupied land, which has been actually passed to municipalities since 2024, and now municipalities are more and more involved to actually occupy that land and start to use it for purpose. Another thing where I could mention about the very important element of using sentinels, the identification of so-called abandoned land, which in Lithuania is very sensitive data, as it is applied actually in the land taxation and the landowners on which parcels the data have been identified as the land has been identified as a abandoned land. They excluded from the decrease of the land tax, means they are paying the max max land tax on this abandoned land. So on the annual basis, we are compiling and updating information on the status of the abandoned land, and the Sentinel imagery is a primary source, but also, of course, we are double checking with information coming from orthophotos and from the georeferential cadastre and land parcel information system as well. So this data is also free and open, so everyone can double check actually on the web and GeoPortal, so where the abandoned land is and either the parcel has any issue with the abandoned land. About land use information was already mentioned by Ernestas and other speakers. So this is the, again, primary source for national paying agency to maintain the national data set on farmland, croplands, and crop fields, and the land parcel information system is based on the Sentinels, but also the other satellite data and drone information, which we intend to use more and more, and have intention to standardize actually and back up the different information coming from drones, imagery and laser scanning information in the future. So that would come to the national repository, and then other public authorities at least would be able to benefit using the different remote sensing information, including the images from the drones. But for the land use, there we have also the high accurate compilation of the land use data there, and the slide data is the key in there. But what I can mention actually in this slide, that the interest on this satellite imagery is growing up in Lithuania. We cannot be proud of let's say matured market for the satellite imaging in Lithuania, but we are augmenting using more and more satellite data in different applications. And for the time being, we see this as an important element in the policy agenda. So, and so, for example, for the time being, data set which is on our radars, like Lucas and Urban Atlas, are not really intensively in use. But with the new policy instruments, like, for example, Soil Directive, we see that Lucas and Urban Atlas might be the first definitive sources for making, you know, the national inventory of the so-called occupied land, as Urban Atlas might provide, and the status of the soil indicators as Lucas data is providing. So Corinne land cover and the other products that we are using from Sentinels, or we observe from Sentinels, which is not intensively used there at national level, is because two elements. One is the resolution, that in case we have a high resolution at national level, so from the national in situ data, then we of course employ the high resolution data. The other problem is the currency. So for example, of Corinne land cover data, which is ongoing now to be updated this year, we see an issue that this is too not enough actually updated information that could be used in operational level. So we can double check it to use as a back control data, alternative source for the controlling what we're doing here, but actually it's not sufficient for the national operations that in situ data are kind of employed as a must. So despite the fact, what I like to stress that we have a great interest on the remote sensing information. And what I really would like to hear from colleagues from European Commission, how actually efficiently we can explore and try to adjust actually data not only from European Space Agency, but also from Copernicus contributing missions, which I have put in brackets here on the first line. So as the different applications require different quality and different elements to be used, and of course, not only data, but also the terms of use of the data are very important, because we are very much in line on the open data, and we like to keep this policy view that whatever government is doing or public authorities are performing, the results, if they are not hurting national security, they could be available to public, free and open. So that would be shortly from my side. Thank you.
Thank you very, very much. Look how punctual we are. Exactly 1 minute left before this. Cool things you're doing in Estonia, Lithuania, and also in our colleagues' institutions in Latvia. For the information, under a contract with the European Space Agency, now Latvian-led Baltic Consortium is preparing an Earth observation platform for governmental services. So that could be another format to help our institutions to uptake this data, as well as to share this platform experience with other countries. So we are very open for this. But now let's go to the next part of our webinar, Opportunities of Earth Observation Program Copernicus for National Statistics. And first, I'd like to invite the European Commission. So first, Tim Lemans will tell us more about the Copernicus program itself. And then Daniel Cantar will tell us more about the Copernicus data space ecosystem and how to use it and how it could be useful for national statistics. So Tim, the floor is yours.
Thank you, Angelina, and thanks for giving us the opportunity to collaborate, to be in this seminar as well. I will tell you a bit about Copernicus in a nutshell, and it will really be in a nutshell, because I've noticed that there are so many experts already in this seminar that what I will be telling is already known to everybody. But since we are with about 300 participants, I hope that it will still be interesting and useful to some of you. So here we go in a bird's view. The Copernicus program is part of the bigger EU space program. It's led by the European Commission, and Copernicus is the part of the space program which is dealing with Earth observation data. It's there for a very long time already, and in the early days it was called GMES. Maybe some of you still remember that. We celebrated our 25th birthday last year, so it's already that long that we are dealing with Copernicus. And in fact, now we are silently gearing up for the next phase. We call it internally Copernicus 3.0, because we work with 7-year periods in the Commission, 7-year multi-annual financial frameworks. And so the next Copernicus phase will start, and we want to continue to support this program, of course. How does it look like in general, the Copernicus program? It is led by the European Commission, but in close collaboration with the member states. Member states are really our primary users, our core users. So we have a tight dialogue with them, with you, in fact. The Copernicus program itself is being put in place by our partners, by our entrusted entities, as they are called in the program. And that is, of course, ESA, who's dealing with most of the space component, as well as EUMETSAT. They are our managers of our space devices. And then we have the services who are put in reality by ECMWF, the Environment Agency in Copenhagen, JRC from the European Commission, Mercator, and then for the security, EMSA, SATSEN, and Frontex. So you see there are many organizations, many people involved in this big thing, this big ecosystem, in fact, which Copernicus is. And I touched upon it already briefly, what components we have. So we have the space component, which is made up of our own satellites, which we call the Sentinels. So the Sentinels are made by ESA and are acquired by the Commission. So we in fact own the Sentinel satellites, which are somewhere high up in the air. But we also get our data from third-party satellite missions, and that we call the Copernicus contributing missions. So they are the two big sources for our satellite data. And as you know, in Earth observation, you are nothing if you cannot calibrate or compare with data from the ground. So we have a very important in situ component as well, which makes sure that we have the necessary reference data there. And that all feeds into the whole Copernicus system. And we have our 6 services who make sure that we have different products in the field of land. A lot has been said already this morning about, or this afternoon, about land cover, about forest cover. All these things are produced by the Copernicus Land Service. We have the Marine Service, who's also providing some statistics about marine. We have the Atmosphere, the Climate Service. Those two are put in practice by the ECMWF. Then we have the Emergency Service, who is providing, for example, activations in the case of flooding or forest fires or whatever. They produce specific background information. And the 6th one is a bit special because the Security Service is not producing full, free and open data, but is really producing specific intelligence for border monitoring, for maritime surveillance, or for external security actions. And then quickly to give you the full overview so you can afterwards look up what satellites we all have. We have a family of 6 families, sorry, of satellites. In fact, 7 because the Sentinel-5 family has a predecessor 5P as well. I think the most of you know Sentinel-2, which is really delivering the visual multispectral images, and Sentinel-1, who's delivering radar imagery. But apart from the Sentinel data or satellites which are already flying around, we are already thinking about the next step. So we are already thinking about Copernicus expansion missions, and one which is maybe most known to many people is the CO2M, CO2 mission, which is going to measure the CO2 in the atmosphere at all times. So this is coming up. Even for the Sentinels, we're already thinking about the next phase, about the next generation, because satellites is not something you set up in a couple of months' time, but this requires many, many years of planning ahead. And of course, you have the contributing missions as well, which are now categorized in emerging companies providing data, established companies, and then non-EU companies. I can still talk for a couple of hours about all this, but I think Angelina will not appreciate that we will go over time. So just as a last slide, how can you access these data? We have many websites on the internet where you can go and look. All the different services have their own website, ESA as well, and the Sentinels as well. We do have thematic hubs which concentrate on a certain topic and which will lead you to the sources where you can find more information. And then we have the Wikio portal and the CDSE portal. But for that, I will completely shut up and pass the floor to Daniel Cantar, who's really our expert on CDSE. Thank you.
Thank you very much. So I can listen for about Copernicus forever, but indeed we are limited in time. So let's listen to Daniel. Thank you very much, Tim. Daniel, if you're talking, I guess we can't hear you. It's fine. Let's wait a bit.
So now I'll try again to share.
Perfect. Now we can hear you.
This will work. So do you see the application I'm sharing?
We see your, yes, now it's perfect.
Excellent. Okay, thank you very much, Tim. I'm going to show and discuss more about the Copernicus data space ecosystem. As Tim has said, we have two overall systems. A Copernicus data space ecosystem, mainly for the data coming from the Sentinel operated by ESA. And then we have Wikio, which is procured by EUMETSAT. So today I'm going to talk with you and to present you the Copernicus data space ecosystem. Aha, now it is the slide. Okay, so really the idea is to have data for continuous monitoring of the Earth parameters. And of course, for this, Tim is presented, and we have the Sentinels. And it's a kind of a carpet mapping sensing of the Earth. So there is really a lot of data to be provided to the users. At the moment, we have above 80 petabyte of data, and we will have over 100 petabyte of data by 28. With the CDAC, what we want to achieve at the moment is to provide all the data that has been sent over the Earth. So we have the full time series to provide to the users, immediately available. So they are not in cold storage, they are in hot storage, and you can access them immediately via S3 and other interface. With this consortium that is providing the service for the CDAC, we want to have a long-term contract, and so we want to have a 6 to 10 years contract. We have started end of 22, so we have a lot of time now to be able to onboard users to use those data directly on the platform. If you do not want to use it on the platform, of course, you can download those data for your own system. We are looking to an open ecosystem when we want people to come on top of the CDAC to be able to provide services with their own application using the data which are available. And those data, as Tim has said, we have the Sentinels, we have digital elevation models, we have contributing missions, and if this is not enough, you can bring your own data to Fuse. We know that usually intelligence is coming from the fusing of different data for the analysis. This is the platform, a schematic approach of the platform. I will leave it for reference to you and go a little bit more onto the different feature. For this platform, we have a public part, which is funded by the Commission, and we have different type of users. We are supporting more from the public user to help them to be able to use. For the statistical office, for example, we are providing specific account where they can do more than the general users. Where the offer is not enough, we are teaming up with the consortium to provide commercial offering, but not only the consortium. The idea, as I said, is to be able to build a consortium, and therefore that there would be other provider, public authorities or commercial providers that can provide their service to the system. And of course, everybody is responsible for what it does and owns its different creation using the platform. If you are a statistical office from the European Union, it's interesting for you to be able, of course, to register a new account on the CDSC, which is normal, everybody can do it, but then go to the help desk and request an upgrade of your account, providing all the information that shows that you are indeed a statistical officer of the Union. And please put a contact person from Eurostat. That would be perfect, and your request will be processed. So what are the capabilities? We have different tools on the CDSC, and of course, to discover the data, the whole archive of data, we have a Copernicus browser where you have the possibility to search and already visualize the data and even do some pre-formatted calculation algorithm like the NDVI and so on. We have Mosaic to help you and Sentinel-2 without cloud. And we have also Sentinel-1 Mosaic, so that you have a series of the data, but of course you can access all the data specifically if you don't want to use the mosaics. With always, you see on the left-hand side the possibility to further analyze the data. If you can do time series over a specific area using all the data that has been taken over this area of interest. And of course, sometimes you would be interested in calculating the NDVI of one field, which you can do over a period of time. And you can take out some statistic information there. You see that this information is a bit strange. It's just that a lot of those data is from Sentinel-2, you have clouds. And if you are taking out the clouds and you see the usual paradigm of cultivation where the crops is growing and then it has been cut down. So the idea is to be able to analyze the data with the different APIs and to show the results that you are getting. Because we have so many data, the idea of being able to do data cubes and to analyze and go through those data cubes is one of the goals of the CDSC. And for this, we are using a streamlined service like Sentinel Hub, provided by one of the consortium companies. We have also OpenEO. This is a very interesting interface, an open source system where you can put easily the different processing modules that you would like, and they are a place where you have those algorithms available, and you have visualization tools. We are looking into integrating OpenEO with Jupyter Lab. Our client, we know that statistical office are using R, and other client to ease user access to those tools with sample notebooks for Jupyter Lab. Also, I mean, of course, those data have been processed in some way on standard product, but if you want to do a specific processing, you have the possibility to have access processors and to do your own processing using those tools. As said, you have hosted environment. You can use the CDSC also as an infrastructure as a service, having access to the data. When you are inside the system, you do not have any quota on the use of the data which are fully available. We have put also a traceability service so that you can ensure that the data that you are using are the official one that has been produced by the Copernicus ground segment. As I said, we really want to build an ecosystem to link with a third party that can use our service on top. And if a third party maybe do not want to use on top of the CDSC the data. We would like to see federation and to federate with those data provider, because everything that is being created, in particular in open manner, it is very important that we can link up, and in particular also for exchanging data and information. We have a service desk to serve you. We have a user forum. What we are trying is to have communities. And for the statistical offices, we are indeed looking. It's an important aspect of the work on the CDSC to be able to serve communities such as the statistical office and to see where information can be exchanged. Of course, you have your own way to exchange your information. But we are looking into the possibility to reinforce these services for statistical office. There will be more and more products as we are working with Eurostat to have a better support for your specific activities, which is have some novelties for us from Copernicus, what Tim has presented. There is a lot of novelties in using statistical information, and we see a great potential there. And of course, I mean, the system, what we are aiming is to have AI and machine learning processes. Okay, this is the end of my presentation. As I said, it's important that you are looking into the Copernicus data space ecosystem and that you are interacting, asking the help desk and looking what is in there for you. There will be more application that in the future, and as we are looking to support the statistical office. Thank you very much.
Thank you very much, Daniel. Quick disclaimer, be careful with these tools. They're very addictive, but thank you very much to the European Commission for really developing all those platforms. They're very exciting, but very useful too. Let's move forward. So now we are going to have a use case presented by Tina Silovic on behalf of the Copernicus Marine Service. Are you here, Tina? Yes, perfect.
I'll start straight away by sharing my screen. Hello everyone, so my name is Tina Silovic and I'm working at Mercator Ocean International, mainly dealing with activities for the Copernicus Marine National Collaboration Program. And today I'm going to present you quite briefly Copernicus Marine Service and touch a bit about aspect of the statistics deriving from Copernicus Marine Service data and how Copernicus Marine Service is also a bit helping with SDG indicators to Eurostat. So Copernicus Marine Service, you already heard a bit before from the DigiDefis and the talk from Tim. It's a Copernicus in general. It's a really big family. There are several different Copernicus services that are addressing different parts of the Earth observation and giving different kind of information about our planet. And Copernicus Marine is the one that is dealing with the marine service. And as all other Copernicus services, there are different entrusted entities that are implementing such data and such services. So in this case, this is Mercator Ocean International. So Copernicus Marine Service is an online catalog representing more than 300 scientifically qualified products. It's a user-driven service. The all data comes in a common form, netcdf file. There is different spatial and temporal resolution for the data, and the data is open and free. Aside of the data coming in this catalog, in terms of ocean products, we are also once per year we have Ocean State Report, which is extensive annual analysis of the state of the ocean. Then we are providing also ocean climate trends, like different trends that are indicating health of the ocean. And then we have also ocean visualization tools that are available to everyone upon the registration, where you can easily focus on the type of data that you need, and you can visualize it in the visualization tools. So we are providing global, regional monitoring and forecasting. So there are three. We tend to define this data in three different topics: blue, white, and ocean. Blue ocean, white ocean, and green ocean, which are defined by the different variables regarding physics, CIs, or biogeochemistry. One important thing to say here is because many times we were discussing about satellite data, but here we have a bit specificity because there is observations are involving not only satellite data, but also in situ data. And both types of the data are used to derive, to have numerical models and forecasts of the marine state. This is also all available in different time formats. So you have multi-year data going back to 45 years, near real-time data, and forecasts that are going from 2 to 10 days. And definitely it all exists for different regions, including global ocean, Arctic, but also, for instance, Baltic Sea. So these are just a brief example of what kind of variables you can find there that exist in different data sets. But I really encourage you to go directly to Copernicus Marine Service website and explore the products by yourself. In Copernicus Marine Data Store, you can filter easily by define your specifications and, as I said, visualize the data or really like just download it to your own computer. So here, for instance, I just filtered on the Baltic, and you can see that there are 63 different products. And within these products, you have many data sets per product itself. All this data is used to develop certain services or downstream services, as we call them, or use cases. So on the website, you can find over 200 different use cases that can be also filtered according to the different topic, according to the region or the country. And there are also some books that are deriving from different topics, like you can have the book of of use cases that are focused on the Baltic Sea. And one of the use cases that I'm going to present, well, basically this is two use cases that are deriving from the National Collaboration Program. So we have this calls for tender where we are supporting users to develop their own downstream service. And this one particularly is Estonian one. So there is an Estonian National Marine Forecast System that comes through collaboration with Estonian Environmental Agency and Taltech. And through this project that they've been funded, they had two different use cases that they developed by using Baltic Sea physics analysis and forecast as a Copernicus Marine product. And these two use cases are really coming from their stakeholders. So one of them, it's a background and operation information for gas terminals and marine pipelines. So basically, the Baltic Sea region has long recognized the strategic importance of liquefied natural gas terminals. So when you're developing such infrastructures, you really need detailed oceanographic and meteorological data just to find the location. And then you need precise calculations for baseline and extreme statistics of waves, sea level, currents, and ice conditions. So all this they had in their use case, in their service. They developed it, and not only to have infrastructure, but also to cover, to have the information about the performance and also about the safety of the marine environment. The other use case is about heat, marine heat for district heating using seawater heat pumps. This was done through it was ordered by Geological Survey of Estonia as a feasibility study to use marine heat for geothermal energy. And similarly, like to other use case, for this one, you also need a lot of information, oceanographic information as a crucial to ensure that these systems are efficient, sustainable, and tailored to the specific marine conditions of the installation site. And this is my last slide where I just wanted to say a few words about Copernicus Marine Service and the work included for the Eurostat, but basically going to have much broader presentation from the Eurostat itself, so I'm not going to go in depth with this. I'm just going to say that we are helping particularly with the SDG indicator that are it's 14, life below water, where there are two different topics that we are trying to address with the marine data. Ocean acidification and eutrophication. And here on the left bottom corner, you can see one snippet from the last ocean state report, just indicating what is happening with an ocean acidification and how they are becoming more acidic on the global level, and in particular with the Atlantic Ocean. And just to state that there has been 30% increase in the acidity since 1985. And here on these blue graphics, you can see marine waters that are affected by eutrophication. And you would need to go a bit more into the graphics itself, but you can see that all countries are indicated here, and some are affected more or less, but Baltic region is in these graphics as well. And by this, I'm going to finish my talk, and feel free to go to Copernicus Marine website, subscribe to the newsletter, or if you have any question, you can write me an email. Thank you.
Thank you very much, Tina. Now we are going to have a presentation about the use case of the Copernicus Land Monitoring Service by Usue Tanesar Hoyos. Are you here? Yes, I see you're here.
Okay.
Feel free to share your content. We're waiting.
Can you all see my presentation?
Yes, we're waiting for your. Yes, perfect.
Is it's in presentation mode?
Yes, yes.
Okay, thank you very much. So my name, as you said, it's I am Usue Tanesar Hoyos. I am the project lead for Copernicus at the European Environment Agency. It has been, I have to say, I will just give first an overview of the service that we are running here at the EA, and then I will present some use cases. It has been very interesting to see how the country representatives were actually mentioning us several times. So that's very good. I appreciate from Estonia, by the way, naming the National Collaboration Program, and we are looking forward to it. So let me see. Good. So what is our service? It is it's actually implemented by the Joint Research Center and the European Environment Agency, but here at the EA, we are responsible for the European part, which is, for some countries, it's more interesting than the global part, although the global component has other data. But anyway, what we are doing is we create geographical information on land cover and its use and its changes on land use, vegetation state, water cycle, and Earth surface energy variables on European and global levels. All our products, of course, are manuals and free and open to the public. And what we do have is, and this was mentioned by one of the speakers before, our data is harmonized and consistent in time and space. So you can expect the same definitions and the same type of product all throughout the EEA 38 plus the UK. You can access our data through our portal, which is included there. And when you access it, you will see that our portfolio is separated into 6 main topics. We have land cover and land use mapping. We have priority area monitoring. By the way, it was also mentioned in one of the previous slides, the use of European Atlas, which falls under the priority area monitoring. We also have satellite data because we give access to the very high resolution mosaic acquired every 3 years by the European Space Agency. We have the geophysical parameters where we are continuous monitorization of vegetation and water, the ground motion monitoring, and reference and validation data. And in this presentation, I will focus on products that are actually that fall under the land cover and land use. And the first one, which was already mentioned here, is the ecosystem accounting. We have, the EEA has a service level agreement signed with ESTAT, and within that, they have carried out a review of our portfolio for ecosystem accounting. It's based on Collin Land Cover, which is updated every 6 years. It was already mentioned by one of the countries that this update frequency is considered to be still not adequate for what they want to do with it. This is something we are actually now talking with our colleagues in-house. The next release of the Collin Land Cover 2024, we are now producing it, and it will be released in 2026. Second example, we are now releasing very soon for the first time a crop type monitoring for the whole EA38. It covers, the first release will cover from 2017 to 2021, but we are now producing 22 and 23, and we'll start producing 24 soon after. There has been some reasons for the delay in the publication, which have to do with the complexity of and the number of layers that we want to release. But in any case, we will have yearly updates of the crop type monitoring throughout the area of interest. And it not only does it include the main crops during the growing season, which is the one that you are now seeing in the presentation, it will also include what we call the cropping or agricultural patterns, agricultural practices, and that includes monitoring of fallow land, monitoring of secondary crops, and of a person. We now have here something that was also mentioned by the Estonian representative, I think, on tree cover density. The tree cover density fell in the past under the high resolution layer forest. Now it has been moved to another product, but that's not important. What is important is that we have moved it to annual updates. And here you can see how an example of the two main layers that are included in that product, which are the tree cover density and the dominant leaf type, and how they will look throughout the years. Then also something that was mentioned here, the grassland monitoring. So in the past, in the releases of 2012 and 2015, grassland layers, I think that they were really suffering from some limitations, probably due to the trade-offs that have to be done when you create a product for such a big AOI, and also with a very scarce input data that was available at that moment, because we have to understand that sentinels were only released in 2017, and so it has taken us a little bit of time. But in general, we are now releasing yearly grassland layers, and we will not only include what was included in the past, which was grassland and plowing events. We also include a herbaceous cover, and we also include mowing events monitorization. And what is also interesting is that they are going to be coherent with the crop type monitoring, with the crop type layers. And finally, another use case, and this is using the imperviousness density that we are, this one is still staying at 3-yearly update. We are now producing the 2021 that should be published in no time from here. And I think this is also a good example of that can support statistical creation. I have to say this, specifically this one, this product suffered quite a lot from a change in the spatial resolution. I will say it before someone else says it, because I notice it has been a bit controversial. It suffered a lot from the change in the spatial resolution when we moved to Sentinel-2, and we are working to support the creation of statistics based on that are also consistent backwards in time. And with this, I encourage you to enter our portal. Also, you can feel free to contact me if you have any questions on this, and we will be very happy to answer. Thanks.
Thank you very much for your presentation. Now we continue to our last presentation of today before we have the Q&A session. So please, Carla Martins from Eurostat. You have a dedicated project about Earth observation for statistics. Perfect for us. Please tell us more about what we can do with that.
Thank you, Angelina. I think my slides are visible.
Yes, we have your first slide.
Okay, thank you. Good afternoon, everyone. My name is Carla Martins, and in the next 20 minutes, I will present the Earth observation for statistics activities here in Eurostat. To start, I will place the Earth observation activities in Eurostat within the European Commission's organogram. So the Earth observation for statistics team includes myself as lead, my colleague Hannes Reuter, our senior GIS and spatial statistics expert, and Zacharias Kandilakis, our Earth observation expert dealing with the more technical parts. The Earth observation for statistics activities are structured within the Geographical Information System of the Commission, the GISCO team. That belongs to Unit E4. That is led by our head of unit, Marta Nagy Rotengas, which presented the welcome just earlier in our webinar. Our activities are part of the Eurostat's Innovation Action Plan, managed by Unit A5, the Methodology and Innovation Unit. Within its various domains, Eurostat harmonizes, collects, and disseminates statistics for EU policy needs. And this is done through the European Statistical System, ESS. That includes the National Statistical Institutes, Eurostat, obviously, and other relevant national organizations involved with statistical production. Like, for example, we deal with the national mapping and cadastral agencies and with the space agencies. The ESS then branches into the European Commission's administrative structures that includes, in our case, links to DG DEFIS, to ESA, to DG JRC, the Joint Research Center, DG Agri, DG Environment, just to mention a few. So this is our ecosystem. Now I will describe to you a bit the mandate of the Earth Observation for Statistics, which Marta has already described to you about the Warsaw Memorandum. So the Warsaw Memorandum acknowledges the urgent needs and the ongoing efforts to make extensive use of Earth observation data in official statistics. And the Director Generals of the National Statistical Institutes agreed on how to implement this Warsaw Memorandum, an action plan. And it laid out a governance framework for implementing Earth observation for statistics that is divided into 5 different axes. First of all, the methodology, guaranteeing that a comprehensive and sound methodological basis is reached. The application of Earth observation in statistics, concrete projects for showcasing and prototyping. The IT infrastructure, making available a sustainable IT infrastructure allowing for the management of the data. The skills, enhancing the offer of training and learning opportunities in the field of Earth observation. The governance, assuring that the right people are engaged and on board so that all the activities have a real impact in the European statistical system, statistical production. The rest of this presentation is structured around these 5 axes. And we will start with the methodology. Here we ask the questions: how to go from Earth observation to statistics, and how to incorporate the Earth observation data in the statistical production process. Not going into detail, the figure here represents in a simplified way the different phases from Earth observation data to statistics. That outer circle represents the Earth observation data directly from the sensor of the satellite. Then the second circle is the analysis-ready data, which is the result of removing the clouds, of auto-rectification and calibration of the satellite data coming from the first circle. The third circle represents the data that is transformed into a proxy that can be done using auxiliary data or simply by interpreting the original data. Some examples have already been showed here, like the vegetated land cover, the dominant leaf type, or the imperviousness. From the proxy, another type of data is generated. The proxy will be translated into data closer to our statistical demands, resulting in crop type maps or in land cover maps. This fourth circle is referred to as a derived product, but it's still not the final stage. The final stage is the statistical table. The statistical table is obtained not only by counting the pixels in the previous data set, but to be considered as unbiased statistics, its accuracy needs to be measured. meaning that the values obtained from the previous phases need to be compared with the reality on the field in terms of its geographical measurement and its classification. In other words, the process is not limited to counting pixels, but the output is rather a spatial statistical product entailing a defined statistical methodology that includes probability and confusion matrices from the several steps of the processing. This will guarantee evidence-based results that can qualify the data as official statistics. This is why the ground truth data that has been already mentioned here in several presentations is essential in classifying the data and in validating it. And the intermediate data and procedures, the corrections and the classifications of the satellite information also needs to be known and measured. So from this slide, there are two takeaways I want to leave here for you. First, the importance of unbiased statistics, meaning the importance of knowing the statistical error. And two, the scope of Earth observation for statistics that concentrates, well, in our point of view, should concentrate on the orange circles of this slide and not on the whole data chain. This means that Earth observation experts will manage the Earth observation data and statisticians will build the statistical data and report the accuracy. The dialogue and collaboration between statisticians and Earth observation experts is key to the success of the project. Statisticians need to know the accuracy of the Earth observation data. National Statistical Institute should focus on the last two inner circles, from the derived data products to unbiased statistics. Deriving a product, measuring the statistical quality and accuracy, and explaining to the Earth observation experts the specifications on requirements in terms of the measurement of the error, in terms of the business continuity, and in terms of comparability. Moving on to the applications. On the applications of Earth observation for statistics, we have compiled a list of projects that use Earth observation data for obtaining statistics. This inventory included a questionnaire to the National Statistical Institutes and also took a look into the work in Eurostat. The inventory is a living document that we aim to continue populating. You can access it through this link here in the presentation. We have chosen some examples of Earth observation for statistics projects to share here with you today. The ecosystem accounting, which has already been referred to in two other presentations, or three, I'm not sure, agriculture statistics in Poland, and some other examples, namely from the GEOS grants and the ESSnet grants. The first example is ecosystem accounting. The ecosystem accounting, which is also part of Eurostat's Innovation Action Plan, by the way. We chose this example because it's at the most advanced state of being integrated into official statistics. This project is now legislated, and data on ecosystem extents, condition, and services is to be transmitted to Eurostat at the end of 2026. Ecosystem accounting will be used as the main metrics for the new nature restoration law. Technologies and methodologies for the production process involve not only Earth observation data, products, but also biophysical models, geospatial data, mapping techniques, other statistics, data from member states. There's a big list. Since 2015, our colleagues from the Environmental Statistics Unit, in collaboration with the dedicated task force, with DG Environment, with the Joint Research Center, have set up the processing tools and guidelines for member states to produce the ecosystem accounts. The second example is on agriculture statistics in Poland, on yield estimations in annual crop production. Late last year, we had the privilege of meeting with Statistics Poland, where we explored their agriculture statistics that is partially using Earth observation as a data input. Here are some insights that Statistics Poland kindly shared with us. First of all, Earth observation from Sentinel-1, 2, and 3 is used. Some variables on crop area and crop yields are produced for at least 3 Eurostat data products: the regional economic accounts for agriculture, integrated farm statistics, and annual crop production. IAX data, which has also been referred here, the administrative data on the farmer subsidies produced by the paying agencies, is used by Statistics Poland. They use a yearly sample of ground truth data from photo interpretation that targets specifically the crops that they want to study, and is aligned also with the tracking structure of the Copernicus data. Data is produced at parcel level, but it is disseminated at a more aggregated level because of data protection. Accuracy is measured using error matrices, quality control on 20% of the sample, and by using estimates of regional experts. Currently, Poland is using its own IT infrastructure. We need to keep in mind that 10 years ago, when Statistics Poland actually started working with Earth observation, shared platforms like the one we just saw presented by Danielle, the CDSC, were not available. The third slide here on the applications is about our inventory, as I had mentioned before, the inventory on the Earth observation for statistics projects. It includes projects financed by the GEOS grants that aim at the integration of geospatial and statistical data. And the slide here includes the links to 2 publications of the GEOS grants where you can find summaries of the projects. The 2024 GEO grant agreements have been just signed at the end of last year, sorry. And the 2025 edition of GEOS grants call will be launched in March this year. The grants from the ESSnet are also a font of Earth observation for statistics projects. I forgot to mention that in the GEOS grants, in 2024, 5 out of 10 of these projects included Earth observation data. So going now to the ESSnet, as I was mentioning, the grants are multi-beneficiary projects involving several national statistical institutes. At least 2 of these big projects include specific work packages on Earth observation. Here you have also the links to the Big Data 2 project and to the one-stop shop for artificial intelligence and machine learning for official statistics. And on the right side of the slide, there's a list of the main themes that we have collected until now in the inventory, the number of projects for each theme, and some examples, like the urban sprawl across urban areas in Europe by the Netherlands, crop recognition with very high resolution data from Belgium, permanent grassland and soil moisture from Slovenia, which I saw in the slides also from CDSC. I saw this project there. The snow statistics in Finland that was financed in collaboration with ESA in the GAUSS project. The GAUSS stands for Generating Advanced Usage of Earth Observation for Smart Statistics. And on transport, we have the use of Earth observation data for detection of containers that is being done by Eurostat's unit E3, transports. Other projects that I include here are the highest hill summits, actually in Latvia, using the LiDAR data. This is not specifically statistical data, but it is reference data for integrating other geographical data sets that will then integrate statistics. We have also the solar panels from the Netherlands and from Germany, a very interesting project on satellite-based economic flash estimates using the construction activity, like detecting construction activity. And these are the examples. As I said, you can find a lot more in these publications. Now, talking to you a bit about the infrastructure, the IT infrastructure, and this is where the Copernicus comes in. We are collaborating with DG DEFIS and ESA We've been collaborating with them since the beginning. And we're trying to explore the capacities of the CDSC, of the Copernicus data space ecosystem. And my colleagues have not referred to this, but the CDSC is the largest Earth observation platform in the world. CDSC offers not only data, but it also offers data processing tools like Danielle has presented, and a repository code that is shared in the ecosystem by the ecosystem users. We have an agreement with DEFIS, as Danielle mentioned, that allows privileged access to the National Statistical Institutes and other national authorities that are engaged in projects on Earth observation for statistics. I know Danielle has mentioned this, but I want to underline this as well. And if you're interested, you can follow the links in this presentation or in the chat and contact us. We're also using the CDSC for our in-house projects on Earth observation, and we work closely with DG DEFIS to foster the uptake of Earth observation products for statistics. Our activities rely heavily on the collaboration with DEFIS and ESA, and of course on the use of the Copernicus data. In close collaboration with DEFIS, we are currently looking into how we can better design into the production process our statistical requirements, so that the various processing phases of Earth observation integrate the data needed for calculating the accuracy that we've just mentioned in the final statistical output. We are looking into this with DEFIS and with the EEA also, that is mostly dealing with the Copernicus land monitoring service. Furthermore, our strategy follows the indications of the Warsaw Memorandum's implementation plan. We privileged open source data and software, as well as shared cloud-based platforms for future common production of statistics, taking the code to the data and not the other way around. Regarding Earth observation data, Eurostat is also compiling a pan-European collection of ortho images that are another pertinent source of Earth observation data, often used to complement satellite data. Although orthophoto maps have a much scarcer time coverage, with at best one image per year, they have, in general, a much higher resolution, which is needed when we aim to detect smaller size phenomena like solar panels or vehicles. And we are currently offering this service of the orthophoto images within the Commission. The next point describes the skills. Initiatives to promote skills for uptake of Earth observation for statistics. Here we have three main messages. The first, training and learning resources collected from several sources are stored in Eurostat's cross-platform. The link is here in this slide. The second highlight is the hackathon. ESTAT is preparing, well, also with DEFIS, the 5th edition of the Big Data Hackathon, and this year the theme is Earth observation. Many NSIs are participating, as well as teams from several universities that are part of the European Masters in Official Statistics. It will be from the 6th to 10th of March in Brussels, just before the conference on the new techniques and technologies in statistics. And finally, the third message is on the European Statistical System training program. ESTAT has carried out 3 courses on Earth observation within the European Statistical Training Program. The next one will be about the Copernicus data space ecosystem. It is a training in presence from the 3rd to the 4th of March, 2025 in Germany in the city of Cologne. And finally, about the governance framework of the Earth observation for statistics. The most important element of our governance framework is the Task Force on Earth Observation for Statistics. Within our task force, we work on disseminating all the information, resources, and activities, collecting and sharing experiences on Earth observation projects, and showcasing the different projects from the NSIs. The task force is essential for the connection to the NSIs and to the procedures of the European statistical system. The task force now has 17 countries, 12 of them are member states, and it includes 12 national statistical institutes and 5 other authorities like mapping agencies and environmental institutes. We have 4 meetings a year. And if you're interested in joining the task force, and you're not in the task force, of course, please let us know, because we are open. We do not want to leave anyone behind. The second element of our governance is the close collaboration with Eurostat's statistical domains and their respective policy DGs. This is essential for matching the statistical needs with the opportunities in the Earth observation data. And the third element is about innovation projects in the member states. We follow closely the GEOS grants, as I mentioned before. A new call is foreseen to be launched in March 2025. And we are following up also with the work package on Earth observation in the one-stop shop for artificial intelligence and machine learning that involves several NSIs. During the next years, this project will transfer the experience of 2 selected Earth observation projects that use artificial intelligence and machine learning into from their original national statistical institutes to other statistical institutes of partner countries. The projects, there's 2 of them. One is on land use and the other is on crop statistics. So we're following closely these projects. And I've come to the end of my presentation. Thank you very much for your attention and interest. Here you have our contact details and links to more information on our activities. The presentation will be made available in the Copernicus website. Big thank you to the Latvian Ministry of Economics and DG DEFIS, our core organizers, for this initiative and for the organization. Over to you, Angelina.
Thank you very much, Carla, for a very informative presentation. Indeed, all the presentations will be published on this event's website. So your, Carla, presentation will be very useful because of all the links included there. So as we see, there is a lot of data and a lot of initiatives ready for the national statistics institutions. And we also see that national statistics institutions are already very active in Earth observation data uptake. So what we need to do is to connect the dots more actively, but we have a very good tendency. I wanted to ask Carla immediately and also others, what are the initiatives for the immediate use for the statistics institutions or for the industry in statistics? But Carla, for example, she covered this question very extensively in her presentation. So I understand March is the very active month for the statistics.
Yes.
Everything is happening in March, especially in Brussels.
Exactly.
Also, for those who are here in the chat, please check the conversations, and we'll highlight it later because, for example, the GRC published very useful information about the upcoming workshop on Earth observation for statistics, and also there will be more and more events on this. So thank you very much for the presenters. Carla, you wanted to say something?
Yes, to answer your question about what we do next. What I take from your question is how do we make this happen, right?
Yes, please.
I would say that the community of statistical offices in CDSC would be an excellent initiative, because it gathers all of the statistical part of the NSIs and into a platform that has the data, that has already some examples of code, and where we could do something in common. Because if we're going to make Earth observation into European official statistics, there has to be some standards. And we need to process everything in the same way. Although we know that the wheat in Portugal does not grow at the same time as the wheat in Lithuania, we need to have a way of making things standard. And I think that the platform is a great opportunity, and a community within this platform would be a nice way. This is just off of the top of my mind.
But to approach the right institution with this question, would you suggest approaching Eurostat directly or DG DEFIS? If someone has questions.
Well,
DG DEFIS can answer.
It has to be, I think, a joint effort.
Exactly. Before we go to the Q&A session, first of all, thank you to all the presenters. The presentations will be published on the website. Also, the recording of the webinar will be published, but the Q&A session will not be published, with the aim of making our discussion more free. So it won't be it will be recorded just to know what's going on, what are the demands, what are the ideas, but not public. So here I'd like to open